Today we'll be covering the module number 6.4, which is type of joins, in which I will be covering the inner join, which is like matching rows, left outer join, the matching rows from the left and the right side table data, and then the right outer join, which will be like matching rows from the right side table to the left side table. Then full outer join, which will be just bringing up all the records from the left table and the right side table. Okay, then the cross join will be like a Cartesian product, that you could say, for each record of the left side table will be matched with the each and every record of the right side table. And then the last one is the self join, which is can be any of the above join type, which is could be like in the self join we could use the matching rows from the left side table to the right side table, and both side name table joined using the primary keys and the foreign key table values. Okay, so that's how it will be. And in the result, what are the results that you would be seeing is what I'm mentioning here in the outputs. Like the inner join, you will bring up the results excluding the null values, only the matching records. Now in the left outer join, you will find the all rows that match with the left table including the null values in the result as is. Then the right outer join will be like bringing up all the rows that match with the right side table including the null values in the result as is. Then the full outer join, which will be like bringing up every rows from both the sides including the null values in the result as is. And then the cross join, which will bring up the total number of rows by multiplying the left side table rows into the right side table rows. Okay, and then the last one, which is like the self join, in that case like brings up the rows based on the type of join, which could be inner join, outer join, left outer join, right outer join, full outer join, or cross join could be, right? So let's just see all of them together in a implementation. Okay, so just a minute. Okay, so let's just start with the first kind of join, which is the inner join. So before we apply any of this type of joins, we need to have some sort of data in the form of table. So for this exercise, or say like for an example, I am just creating a dummy data. So bear with me for now. Like use I'll be using the learning DB first of all. So we'll just select and use that the learning DB. So now it is in use. Now we will be dropping if any of these tables are existing already. Maybe for an previous examples I might have it created with the same name. I just do not want to make sure like it gets dropped and then recreated with the given values. If there is any values, then you may need to use this truncate statements, which is not required in this case if you drop these tables earlier, right? So if in case you do not do the drop of the table, then only you might need to do the truncate, provided the table structures remains the same, matching with the prior execution. Now in the case of insert statements, I'm just putting in the single column value, which is like 13575, and then the null into the ID column of integer type. Okay, then the second table I'm creating which is of ID integer, and then the manager ID is in the integer type. Now the values that I am inserting into these two columns are like the first row I'm adding up as the ID as 1, whereas manager ID I am putting in willingly none. The second row I am inserting the ID as 3 and then the manager ID as 1. Likewise, I have added all 6 of these records or 7 of these records, including the last one having both the values as null. Okay, that is deliberately I am inserting a null values just to show you some different combination of the result set, right? Now let us just start with understanding of the inner join. As we just understood from the presentation that like inner joins will always match the rows from both the side tables, and then in the output what it will bring is it will bring up the results excluding the null values. Meaning suppose say if there is a null value here, at the same time it is null here, it may not match and it may not bring up the null values in the result set in the case of inner join. Okay, it will always omit. Just remember this, always excludes null. Okay, null values basically, or say like a null rows, I would say null values. Okay, now let us just see first of all like what are the values that we inserted into these two tables, and then we see to the third query. The third query is very simple. I have written like select then T1, which is like my table 1 dot id, and then my table 2, which is this the second table, and then I'm giving it an like a table 2, I'm giving using the same id column for that as well. It has the id column and then the manager id column, so I'm just joining up both on the id column for now. Okay, so let's just run all of them together. All right, so here we see like the id is representing 13575 null, and table 2 has 135797, right? Now to match each of this table, I mean both this table, how it will go and match and insert in, add it in, into the output is like it will start matching the first record with the first record of this table 2. It will check like if there is a match into this table, the table 2. If it is a match, then it will insert it in here. If it is a null, even though it will put it I mean here we are not considering the manager id column, so for now just try to understand both these columns only. Okay, so say like if one for a 1 it is there is a match, then it will insert 1 as a 1, and then there is a second row, it will go 3 into 3, which is like 3 to 3. Then the fifth also has a match, so fifth also will be displayed. Then 7 again, so 7 will be displayed because 7 is also there, right? And then there will be fifth again, so fifth will be matched with the fifth again. That's how. And then like 7 already had 2 sevens into this table, so always remember whenever there is a repetitive values into the column matching to the left table or to the right table, irrespective the type of join, it will bring up those records into the result. Okay, so for that reason, as we are seeing here, like the fifth was there, for that reason if there were 2 5s and there were only 1 5s, still there are 2 outputs, because for each 5 onto the left side it will have a single combination matching to the right, so that it will bring up both these records. Likewise, you have one record from the left side table having 7 as a value, whereas right side table has 2 7s matching to the left table, still it will be returned into the result. That is what the result of inner join. Okay, now we will try to understand the left outer join. Left outer join will do what? Matches the rows from the left side table to the right side table and brings all the rows that match with the left table, including the null values in the results as is. So in this case, or in this type of join, nulls will also be included into the results, and matching rows from the left table to the right table will be returned into the result. Okay, so let's just see running them together. Let's run them. Yeah, so now we can again compare to see that like how many records from the left side is there? 1 3 5 5 7 and then null, right? And right side table 1 3 5 7 7 9 and null. So how many records it has written? 1 3 5 7 7 5 and null. So this time you see like this additional record has come into the output, which is null. So it has matched all the records or all the rows from the left side table, including the null value, and it has returned it into the result, right? Now let us just try to understand the right side outer join. Right outer join will be again the similar, just the change of a side you could say, or just swapping the tables, whichever way you could say. So like matching the rows from the right side table to the left side table, and resulting means output will be like all rows that match with the right side table, including the null values in the result as is. Okay, so let us just run again. All right, now we'll again see how many records are there on the left side table. 6 records. Right side table has got 7 records. How many records we found it in output of the right side right outer join is 8 records. Why? Because we had 1-to-1 match, this is 1, 3-to-3 match, this is 3, then 5-5 2 times match, so 5-5 2 times match, 7 1 time match, 7 has got 1 match, then 7 has another match as well, so 7 is another match. One more match from the right side table, which is null here in this case, or sorry, you could say like the left side table has got null, whereas right side table has an additional value or called 9, which was not there on the left side table, so that will be returned as if like 9. So whenever there is a value in the right side table and there is no value on the left side table, it will be replaced as a null. Okay, for that reason we are seeing here null value, and right side we are seeing the 9. Okay, now 7 we already saw that it is compared, 7 and 7. Now the last record, which is the null record, in that case both the sides it will be null, because the last record we are having null value on the right side table, which is also the case. It may not be compared with this table, but instead it will be just returned as is into the right side table. Okay, so for that reason it is like 8 records from the result of right outer join. Now we will try to understand full outer join, matching rows from both the sides including the nulls. Okay, so let's just see running them. Syntax are very similar, just change the keyword from here. Like in the first case you would say inner join, then you would say left outer, or you could say left only, whichever way you want to say, like left outer or left just left keyword, both of them are valid. Here also, like instead of inner you could write like a join only, because it by default considers it to be inner join only. Okay, now in the case of right outer join, again you can skip this keyword outer from the join type, then you could just say right join, it will still consider it as a right outer join only. Okay, now we'll run this full outer join. There also you could just omit or skip this keyword in case you want to, but I would always recommend to write it in the full, so that you don't get confused or maybe no confusion later stage. All right, so let's just run the full outer join. Now full outer join, earlier the case it was returning the 8 records, but now here you see like the 9 records are written. One more record, because one null record from the left side is considered and one null from the right side is considered, this, right? And then the different record was in the right side table, which is this. Rest of the table, rest of the records were same, 1-to-1, then 3-to-3, then 5-to-5, 2 times 5 and 2 times 7, right? All of them were identical for throughout all the results. Only the difference was in the right side outer join, and then the full outer join, it has like a 2 separate records for the null. All right, so this is how you will understand the full outer join. Now comes the cross join. Cross join is like a Cartesian product, we understand from mathematics, is like multiplying, or say like doing a product of each record from the left table with the right side table of right side row of the right side table row, right? So let's just run them together. The syntax of the cross join will be little bit different. In all of the other kind of joins, we will just put in the joining condition after putting the this name, right? Like right side outer join, we will put in the another table, and then we will put in the keyword called on, and then put the joining condition on what column you would like to join these two tables, right? So from the table 1 we were using the ID column, and from the table 2 we were using the ID column, so both the columns were same. Okay, but in the case of cross join, you may not see that on condition, and you may not even need it. Why? Because it is by default considering all the records. and it doesn't require this on condition at all for this. Okay, so let us just understand executing this. All right, now as you see, how many records are there in the first table? 6 records, correct? 6 records from the first table and 7 records from the second table, correct? Now product of 6 into 7 will become what? 42, correct? So that many records we should have in the result, which is the correct result here. 42 records is what we are seeing here. Why and how? Let us just see. For each record from the first, meaning like the first ID, it will go and it will match each and every, it will print each and every record of the right side table. It will apply this one as a product against each and every rows of the right side table. So say like 1, 3, 5, 7, 9, 7 and then null, right? So for that reason there are 7 records into the for the value 1. Again the same way, the third value will pick up this record and then try to match each and every record. Consider say like just we are using the same values and the left side value will remain same for each of those, correct? That's how it will be. Okay, so likewise up to how many times? 6 times it will go, even for the null as well. See, for the null also the right side rows will still be copied. Okay, so for that reason it is the result as 42, right? Understood? So let's say now the last kind of join, which is the self join, in which like what happens basically, self join is generally we use in the case like to create the hierarchies. Maybe like you have the relationship between those two tables of your say like employee and the department tables, and then you may have the manager into your employee table itself probably. Okay, and even you don't need department, instead like you just have the employee table, and within the employee table you have the primary key applied onto the ID column, whereas your manager ID will be your foreign key, say. Okay, so within the same table you will have the primary key and the foreign keys self-referencing in that case. So the manager values you would see is ideally be the employee ID values only. Okay, so now let us just see into the action. Let me do one some cleanup thing before I actually prepare the stuff for that. So I'll just remove the previously inserted or updated values and just change the table for the purpose of explanation, or say that for example I'll be removing any of the nulls. Why? Because I may need the primary key column to be applied. Whenever, always remember, if you have a value, any single value into this column called ID as null, it will not allow you to create the primary key on top of it, because you inserted the records into the table and then you are trying to insert the then you are converting the table into the primary key. It may never allow it to create it. Okay, so for that reason you need to make, or either you need to remove it, or you need to put some placeholder values, or maybe put some default values to that, then it will be, or it can be applied on to that, right? So here we are trying to alter this statement, alter the column, but before I do, I wanted to say I just want to remove those null values instead of that, right? So I'll just remove it. Okay, so it's got removed. Then what we will do is we will alter the table for the ID column and make it what? It will be not null. Even though, always remember, it just not the values makes the difference while creating the primary key, but also if you have this column name was if the column was created as if like nullable, if you don't declare anything here, right? If you when we created this table, you see like when we created this table and ID integer column, we did not specify whether it is not null or it is null. By default, what will happen is it will consider the column as null if I will not mention it as not null always. Okay, so remember that if you did not mention here anything, meaning it has considered it as a nullable column, and nullable columns will never be allowed to make we are not allowed to make them as primary key. Second condition. Okay, so before you try to make it, you need to make the column as not null. Only then and then it will allow you to make your column as primary key. For that reason we are making this change. Alter table, table 2, and then the alter column, the ID type will remain same, only just we are changing the constraint on top of it. Okay, so just changing it, and then we will apply the update statement. Now update statement, I'll tell you again why am I updating this statement. Earlier the ID value for say where the ID was 7, right? What was the value that we had given into the table number 7, right? Let's just see, ID 7, right? What was the value for that? It was having some duplicate, correct? Again, third point, before you try to make the column as primary key, that is again you need to remove the primary key values so that it can allow you to make the column as primary key. Always remember, let me repeat all those 3 points. The first one was the table should not have any single null values within that. Okay, that is the first condition. Second condition is like while you created the column, you should not have the nullable column. Then also it may not allow you to make the column as primary key. And then the third condition, when you try to make the column as primary key, it will never allow you to have any duplicate values within. If you have any single record repetitively existing into the table, then it will never allow you, which is available in this example that we see. How it is what I'm saying, like here you see like the ID values are repeated twice, 7.3 and 7.5, right? Which is repetitively given, because we never made that column as an identity, or we never made that column as like primary key. For that reason we made it repetitive. But here just to show you the like the inner join and all this kind of joins, I have deliberately added those duplicate values. But just understand me what I'm saying. When you need to create the primary key, you always need to remove such kind of values from the table, or you may need to update such kind of values into the table, right? What we are doing to we are making change here is we are changing the ID from 7 by making it as 11. So what we will do is we will change this record from 7, because there are different values 1, 3, 5, 7, 9, and then I will make this 7 as 11. Okay, that is what I am trying to make now using the update statement. Okay, here we were, right? So I'm just checking the condition for the ID equal to 7 and manager ID equal to 5. Just set the value as value of an ID as 11. So we will change the record as this, right? So it is updated. Now the last thing is remained, which is like to apply the primary key onto ID column, correct? Now it will allow you to create the primary key. Then you want to apply the foreign key onto the manager ID. Now there is no constraint, such constraint of nullability gets applied for the foreign key. Foreign key does allow it to be it to have the null values even within the foreign key column. Okay, so manager ID, if you see, manager ID did have couple of null values within that, but it doesn't have any issue with it. Okay, when you want to make it a foreign key column, it doesn't have any issue with that. So let's just execute this one as well. So primary key, what we are making change here, we are making change in the 3 columns. The first one, we are adding new column of employee name here, because earlier there was no employee name I added. I just vaguely gave the 2 table names as like T1 and T2 instead of keeping it like employee and department or something. I just gave it like T1, T2. But now say like for this example, to convert into the hierarchical way or to represent the self join, I need to make, or I need to add some kind of name for that particular employee, so that you may understand which employee it refers to, right? For that reason, I'm adding a new column called employee name in the format of varchar 10. Then the constraint I'm applying onto the ID column of the table 2 as primary key, okay, and that is the column ID, okay. So the constraint, then the constraint type, and then the constraint name, and then the column name, okay. Same way, constraint type, which is foreign key, table 2, manager ID is the column, then the constraint type, foreign key, and then the column name, manager ID, then references to which column of this table is T2. T2 is our current table, and what column it is going to refer is ID column, okay. So that is what we are writing and executing now. All right, so executed successfully. Now we will run this update statement. Now let me explain again this employee name. Now employee name column we created here, it is like very simple for me to explain or say like update 5 to 7 records, but supposingly now like you may have thousands of values for an employee, and now if you want to do such kind of an update, how you would do an update, you might need to create a separate set for such kind of thing, okay. For now, for in this case, for an example, I am just taking, or I'm just preparing some dummy values like this, but in your case you may not go and write like 1000 case statements for that, right? It will be time consuming, at the same time it will hit the performance of the queries, right? So best practice to do that kind of an update will be prepare a separate set such that like it can be updated from that particular set directly into this table rather than doing the row by row operation, okay, because this is like a row by row operation. If you apply it directly as a join and do the update into the particular table, it will be like a set based, meaning like the one shot everything will be updated. It will not go row by row and do the update operation, right? Which will be performance wise it will be better. So let us just understand like how I'm preparing the values for all these 7 or say like a 6 rows into the table. So 6 IDs were there, 1, 3, 5, 7 and 9. So for each of these I am putting up some dummy values for the employee name, say like A, B, C and D and E, F, right? E and F. So all IDs will be giving and updating the values using the update statement. Let's just see. So the syntax of this we will be considered, or we will be understanding in a subsequent module, but for now just understand as if like update is the keyword that you would write, then the table name, then set meaning like which column do you want to update from the table to, that column name you will write, equals to what the value you would like to replace it with, okay. So the value that we will be replacing is, we will be using the case statement, as we just understood in the last module that case statement how it can be used is like this is the second case, like the searched case expression kind of thing, in which like you will just compare this logical or say like boolean expression, and then the returning value will be your replacement value for each of the case. Whenever there is a ID equals to 1, it will be replaced with value called A. Whenever there is ID will be 3, then it will replace its value as B into the column called employee name. Likewise it will do for all the other IDs. Let's just see by executing it. All right, so 6 update has happened, so that result is 6 rows are affected meaning updated, okay. Now let us just see all of the 6 rows how they are updated into the T2 table, right? So let's just see ID 1, 3, 5, 7, 9, 11. Manager IDs will remain same, no change. The first one was empty, and then employee names how we define, that is how it has been updated, so no issue within that. Always remember or make it a practice that when after you do an update or insert operation, you verify the data into the respective tables. Now after this update has been applied into that, now what we want to achieve here is we want to represent now we want to represent the table records, say like how we want to display as like how can I say, okay, in the case we want to display 4 columns into the output, okay. Now what are the values we would like to display into the output is, first column we want to display into the output is the employee ID, then we would like to display the employee name, then we want to display the manager ID, and then we want to display the manager name. Okay, so that's how we will be displaying all 4 records from two different or from the same table basically. Okay, so just carefully understand. So far in the other type of joins we were just using the different tables, T1 T2, here like full outer join also T1 T2, right, like right outer join, full left outer join, and then the inner join. Everywhere we use the 2 different tables, but here in the self join, always remember in the self join itself meaning like you are going to use both the tables as the same table, only just the different columns you might be joining them on. Okay, so the left side table here is T2 and the right side table here is T2 again. Now the columns which we are going to join from the table on the left hand side is manager ID. Manager ID is what we will be comparing it. See, this is the manager ID, that is the column we will be comparing it with right side table, the ID column. Okay, so that is how we will be comparing the right side table meaning T2 table, but we are given the alias as B. So B table ID values is what we will be comparing. So basically which values will be compared? So 1 to 1 will be matched, 1 to 1 will be matched, then 3 to 3 will be matched, and then 3 to 3 will be matched, 5 to 5 will be matched. Then there will be no match for all these 3, correct, because they do not have any of the for them like there will be no match, right? So basically only the matching rows we will have the records coming up into the output, right? So let's just see, and that is why we are just trying to compare the left side result. So the left side tables which will have all the IDs within that, but it will have a limited number of employees onto the right hand side, managers. So let's just execute. Now here you see we are applying a left join onto that. There is no keyword called self join. Okay, for that we may have to use the left join in that case for this scenario basically. Otherwise we could use the self join as well, but here in this case we want to use the left join based on the condition that I want to explain you here in the example. Let's just execute now. So you understand that, okay, like on the left hand side we are having the employee IDs 1, 3, 5, 7, 9 and 11, or for each of these employees the name of an employees are like this, whereas the respective manager IDs are this, right? Now so in that case the first employee whose name is A doesn't have any manager ID assigned to it, will not have any manager name for that. Now you may ask the question, why this first employee you kept it as null and did not give any value to that? Consider, say, like you may have number of employees working in an organization, right? Now for each and every employees you may find that their respective department managers will be there and then they will be reporting to them, correct? But here in this case you may have a top level manager or top level management person like a CTO or CEO kind of person. Above to him there is no one, right? For that person there will be no reporting person or there will be no reporting manager for that person because he will be the topmost level of hierarchy, correct? For that reason we are keeping this record as a null or say like an empty. And for that reason we do not have any records matching for the manager ID for that employee. So consider, say, like this is a CEO kind of record that we have in the table, and for that reason we are not having any manager ID for him. But the department ID, maybe the third number employee is referring to, then his name is BBB, is reporting to whom? He is reporting to A, meaning employee ID 1. So the employee ID 3 and 5, or say like 3 and 5, both of them are reporting to whom? Both of them are reporting to 1, means like CEO or some kind of top level person, right? Then comes the 7. Now 7 is the D 9 is E, and then 11 is F. 7 is referring to which employee ID? 7 is reporting to third number of employee, which is the second record. It is referring or reporting to 7 and 9. Both of them are reporting to third number employee, which is B. Correct? For that reason, they are matching up here. And then the last record, which is like 11 number employee, which is F. It is reporting to employee number 5. Name is CCC. So the third number of employee to whom 11 number employee is reporting to third number of record. The employee number ID, employee ID 5, and then the name is C. Right? That is how the hierarchy you can create using the self join in this case. Right? So that's all I just wanted to cover up into this module. So happy learning. Have a nice day. Thank you.